So today we're doing permutations with repetition. So let's look at this. A bookstore is advertising signed copies of books about 3 famous Canadian hockey players in the Hockey Hall of Fame: Wayne Gretzky, Patrick Waugh, and Steve Yzerman. The books are arranged on a vertical display stand. One possible arrangement is shown. Sketch the possible arrangements of the 3 books. How many different arrangements are there? Okay. So if we went and sketched them out, we could have a Gretzky, a Waugh, or an Yzerman. Or we could have a Gretzky, an Yzerman, or a Waugh. Or we could have an Yzerman, a Gretzky, or a Waugh. Or an Yzerman, or a Waugh, or a Gretzky. Or we could start off with Waugh, Yzerman, Gretzky, Waugh, Gretzky, Yzerman. So, okay. So there's 6 different ones. 6 book arrangements, not books. 6 book arrangements. Okay. Now, instead of doing the different arrangements like that, we could do the fundamental counting principle, and we could say, how many options do I have for this space? 3, all 3 books. Then I leave one there. If I don't leave one there, I'm starting all over again. It would be a vicious circle of putting down a book, putting down a book, grabbing it back up. You have no books ever to display. You just literally be picking it up and putting down the same book. So 1 has to stay here. Then you'd have 2, then 1. 6 times 2 times, or 3 times 2 times 1 is 6. So same thing. However, next question. The book sells out the autographed Wayne Gretzky book, including the display copy, so there's none left in the store. The sales clerk replaces the Wayne Gretzky book with a second copy of the Patrick Waugh book. Okay? One possible arrangement is shown. So Waugh, Waugh, and Yzerman. So how could we do this? We could go Waugh, Waugh, Yzerman, or Waugh, Waugh, Yzerman. Boy, I sound very similar, because can you tell the difference between these? Pretend that the books are perfectly the same. There isn't like a bent corner on one of them. This is the same thing, correct? Okay. What about Waugh? Nope. Yzerman, Waugh, Waugh, Yzerman. Then I'm going to flip the other Waugh, Waugh books. But because they're in perfect same condition, no difference. Then I could have Waugh, Yzerman, Waugh. Or flip my Waugh books. So Waugh, Yzerman, Waugh. Fun. So how many do I actually have? Only 3 different ways, right? Because those 2 books, you can't tell the difference. Now, it would really not be that much fun, if I had to always list out all my combinations, especially when there's like a million combinations, and then cross off the ones that are common, the same thing, right? That would not be the most effective way. There's got to be an easier way. So what you do is you just treat it like there are no repetitions. So that's what you do on the top. So on the top, you treat it like there's no repetitions, that the different Waugh books are different. So I would have, just like I had last time, 3 options for this blank, 2 options for this blank, 1 option for that blank. Okay? So I have 6 options. So I just treat it like there's no repetitions at first. And then I just divide off the repetitions. So I'm going to divide off 2 factorial. So if there's 2 that repeat, you do 2 factorial. If there was 3 that repeated, you do 3 factorial. Okay? So then you'd go 2 factorial is just 2 times 1, so it's 2. 6 divided by 2 is 3. So you always treat it at first as if there's no repetitions, and then all you do in the end is you take off those repetitions. Okay? If you have your phone up, please put it away. The number of arrangements in B is equal to the number of arrangements in A divided by 2, right? Just because of that 2 factorial. Okay. In the past lesson, we investigated the number of arrangements of all the letters in a particular word. In every case, the letters in the word were different up to this point. And I told you there was going to be a point where we'd have to check our words always to see if we have double ups or triple ups. In this part, we investigate what happens when you have letters which repeat. So to examine the scenario, we're going to look at the word rows. If you look at the word rows, you could list all of these out, which would take forever and you might miss one. Or we could say, hey, how many ways can I rearrange rows? Well, the first blank, how many letters do I have for it? R, O, S, and E, right? So I'd have 4. Then the second blank, how many letters would I have? 3. Then, so there's 24 of them, which up here there's 24 as well. Okay? And that's what we did in the past. If you just rearrange the one word, you'd literally just go all the way down, or 4 factorial even is 24 as well. But now we're going to change the E in rows to S. So now we have Ross. So we do just the same thing as we did before. We treat it like R, O, S, S are all different letters. But remember I told you when you write out the word, always go like this, R, O, S, S. So you realize that there's 2 that are the same. You need to do that so that you remember to divide by the factorial of them. If not, you're just going to go 4, 3, 2, 1. Give me that answer. That answer will be on the diploma and on your unit test, and it will be wrong. So we don't want to be that, because we don't want a wrong answer. So we treat it just like they're all 4 different letters. So we'd have 4 options for the first, 3 options for the second, 2 options for the third, 1 option for the fourth. So we have 4 factorial. And that would be the same as rows, right? But we don't have all 4 different letters. We actually have 2 that are the same. So we have to divide by 2 factorial. Because that's going to count out, that's going to cut out all of these issues. When we have Ross and Ross, this 2 factorial takes out all those ones that are actually the same. So RSSO, RSSO, RSOS, we have another one, right? So instead of listing them all and then crossing off the ones that are the exact same, this is faster. We do it like they're all different, and then we divide by the factorial of the letters, and it will get rid of all those double ups for you without you having to physically cross them all out. So this is 24 divided by 2, which is 12. So there's actually 12 ways that we can rearrange Ross and get different words. Okay? Because Ross and then Ross, the 2 S's switched to still Ross. It doesn't change it because they're the same. Now what happens if instead we change it to the word Rus? That's such a nice word, I know. So this RSS is the same as this RSS is the same as this RSSS is the same as this RSSS. So these would all be gone and we'd only have 1. Oh, there's some more. This RSSS and this RSSS. Okay? That is not the easiest way to do it. So what do we do? Just the same as we did before. Treat the top as if they're all different letters. So I'd have 4 letters for this one, 3 for here, 2 for here, 1 for here. So I have 4 factorial on the top, or 24. Same amount of options. But now instead of dividing by 2 factorial, I have R, S, S, S. Now I'm actually going to divide by 3 factorial. 3 factorial is 3 times 2 times 1, so it's 6. So it's 24 divided by 6. So I only have 4 different ways that I can write RSSS differently. Then flip over. Okay, well, my computer decides to be nice. Okay, Vancouver. V-A-N-C-O-U-V-E-R. So we have 1, that's funny. So you have 2 V's and 1, 2, 3, 4, 5, 6, 7, 8, 9 letters, right? So you'd have 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 on the top, or 9 factorial, divided by how many double ups? 2. What is that? I cannot do that in my head. It's not possible. 9 times 8 times 7 times 6 times 5 times 4 times 3 is, what'd you get, Parker? 181, 440. We agree? Okay. Mathematical. M-A-T-H-E-M-A-C-A-L. We have 2 M's, we have 3 A's, we have 2 T's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters in mathematical, right? 11, 12, yep. And then we divide by 2 factorial, 3 factorial, 2 factorial. Now, when you put this in your calculator, you guys, if you go 12 factorial divided by 2 factorial, 3 factorial, 2 factorial, and this not in brackets, your calculator is going to go 12 factorial divided by 2 factorial times 3 factorial times 2. That's what your calculator will do. You need to put it in brackets, or you need to do the top and the bottom separately and then divide them. That's the only way. So I get 19,958,400. If you got something different, check and see, because if you just go 12 factorial divided by 2 factorial, 3 factorial, 2 factorial, your calculator will be multiplying by 3 and 2, not dividing by them. Brent bought a carton containing 10 mini boxes of cereal. There are 3 boxes of cornflakes, 2 boxes of Rice Krispies, so 2 Rice Krispies, 1 box Cocoa Pops, 1 box Shreddies, and the remainder are Raisin Bran. So 3 plus 2 is 5, plus 1 is 6, plus 1 is 7, so that means there are 3 Raisin Bran. Now, you cannot tell the difference between the boxes of Raisin Bran. They are Raisin Bran. Maybe they have a few more raisins, but you don't know. You don't know. You're not going to count them. You don't know. Okay? Don't fight it. They're the same. Over a 10-day period, Brent plans to eat the contents of 1 box of cereal every morning. So we could go on the first day, he had 10. Then on the second day, he had 9. Then on the third day, he had 8, 7, 6, 5, 4, 3, 2, 1. Correct? Or 10 factorial. Then he has 3 boxes of cornflakes, 3 factorial. 2 boxes of Rice Krispies, 2 factorial. And then you could go 1 factorial, but there's no point because that's 1. When you multiply by 1, it does nothing. And then 3. And you get 50,400. Different ways he could eat. Oh, wait a second. What's the catch? This would be correct if it didn't say, on the first morning he must eat Raisin Bran. So what it ends up actually being is the first morning he has not 1 option. How many options does he have on the first morning? 3. Because he has 3 Raisin Brans, right? And then how many boxes do I have left? 9, 8, 7, 6, 5, 4, 3, 2, 1. All over 3 factorial, 2 factorial, 3 factorial.